stored in the memory, and how the data is retrieved, and how the data is actually managed within the database. So that is what we have seen in the previous class. And we have also seen about the different components, different users who interact with the database. So can I get some responses? Can you give me who are all the different type of users who interact with the database? So if you are able to give it in a chat, or if you want to unmute and respond, you can respond. Or else I may be like calling someone of you to unmute and answer. So who are all the users who are interacting with the database according to the architecture we have seen in the previous class? Okay, Jivas, very good. Okay, so we have seen about the naive users and the database administrators, and then only naive users and the administrators, and who are all the other people? Application developers, and who are all the other one more user? Four users we have seen, right? Ashinger, can you unmute and respond, ma? Who are all the users who are interacting with the database? So if there is no response, no, I'll be marking absent. Okay, I told already there should be perfect response. Okay, so whenever a question has been asked, okay, so, and I could see that Ashinger was not able to answer to the question. And Surya Bharani, can you tell me who are all the users who are interacting with the database?
Ma'am.
Yes, Rasanjar, you can respond, but I don't think so. Your environment is that much.
Ma'am, application sophisticated, ma'am.
Oh, very good. Okay, so application developers and sophisticated by
Ma'am,
Surya Bharani. Okay. So
ma'am, I don't know the answer, ma'am.
Assenger, I didn't get you. I think you
Eh,
have some trouble in unmuting.
Okay, ma'am.
Okay, so appreciation to Surya Bharani, Assenger. I'm helpless with regard to your attendance, ma, because you're not able to unmute, and your environment also not sounds to be good. Okay, and then we have also seen about the next important component, the query processor and storage manager. So, what is the functionality of query processor? What is the responsibility of query processor? Uh, if somebody is there who can unmute, or you can put it in the chat, it is good. Okay. If not, I have to like pick out someone. Okay. So, okay. Very good. Translation, okay, and execution. Maria has given the answer. Very good. So, mainly the functionality of query processor is to translate and execution of SQL statement by the database engine. Okay, so translation of SQL statement into a low level instruction. Okay, that's why we have the TDL interpreter, and then we have DML compiler and linker, and then we have the application program object code. So very good. So one more component that we have seen in the previous class is storage manager. Okay, so what is the functionality of storage manager? So I could see that people are able to respond like Jivas, Maria, okay, appreciation, and even Surya Bharani, excellent. So, but then the other people also can involve. Okay, so that will help us to recollect at least the terminologies. And what is the functionality of storage manager? And if there is no response, also I have to like pick out someone. So Irban is there, Irban Adil. Accenture
Yes,
is
ma'am.
not able to. Irban, can you give me like for what purpose or what is the functionality of storage manager? So Irban also seems to be little busy. Okay, and Ashenger like Irban, again all those people are little busy. And Joel Jairaj,
Ma'am,
can
ma'am,
you
it is used to manage the data and data space, ma'am, in databases.
data space to manage the data space in database? Okay, so Joel has given some answer. Okay, mainly it is used to manage the data storage and retrieval and updates of data in the physical storage. Okay, so especially mainly we speak about how the data is stored in the hard disk. Okay, so where it focuses on the physical storage and the database security. Okay, so storage manager is much concerned about the physical storage and the database security. So I encourage every one of you to continue to pay attention. So appreciation to Joel and appreciation to Surya Bharani, Jivas, and Maria. Okay, so on all the students, though it is an online mode, they are able to pay attention to the class. So now let me share my screen with you all for today's class. Okay, so today we are going to move on to the next topic that is called as relation algebra. Okay, so relational algebra, why we need to go? So till now we have seen all the kinds of operation. Okay, so we have learned and how the SQL computations are written. Okay, for a simple question, how will you write, formulate an SQL query? So, but this relational algebra, this is a procedural language. Okay, this is a procedural query language that makes use of operators in order to perform a query. So, mainly it has some collection of operation that takes two or more relation as an output, okay, and will produce one single relation as an output. Okay, so sometimes you might depending upon the query you might require to retrieve the data from more than one table. Okay, so or sometimes the computation have to be done only within the instances of one single table. Okay, so this is about how do we make use of the operation. Either you do a combination of a retrieval of data or you selectively perform the computations on one single table. Okay, and here we have the basic fundamental operations. We have select, project, okay, union, set difference, Cartesian product, and rename. Okay, so we have six basic relational algebra operation. We have six basic relational algebra operation. So these six operations are represented by these symbol. Okay, so here select operation is represented by sigma and project operation is represented by a pi symbol and union, this is the set representation and set difference. Okay, so union, it is an operation that helps you to retrieve the instances from two table. Okay, and set difference, it is an operation that helps you to eliminate some of the instances from one table. So Cartesian product, it is an operation that will take each and every row of one, okay, and it will combine it with all the rows of the second table. Okay, in mathematics we have seen, you would have studied about the Cartesian product. And rename, so how normally in query, how we will do a rename, you will change the table name. The same way, rename in the relational algebra notation, it is represented by a row symbol. Okay, so and all these operators will take either one or two table as an input and after computation will produce one single new relation as a result. Okay, so the first operation, it is a select operation. So select operation, what do you mean by the select operation? It is like selecting the subset of rows from a table that are satisfied, okay, based upon a given condition. Okay, so say for example, you have a table, okay, so and you are writing some query. So I would like to know about the list of students who have secured above 8 CGPA. Okay, and in that case, you will write a query and you will put a var clause, right? That is called as condition. Okay, so what does a select clause signify? And already I told select, it represents what are all the column you want to select, and from it signifies from which table you are doing this computation. Okay, and var, it is a clause that is mainly that helps you to either select the rows, okay, or it helps us to remove the rows from a table depending upon the condition. Okay, and the representation, it is a Greek letter which is sigma. Okay, so don't forget, so select operation is represented by sigma, and we have this operation can be used along with the comparison operator depending upon the condition. Okay, so I told I want to visualize the students whose CGPA is above 8. Okay, where CGPA greater than 8. Okay, so and how this is done, what is the notation? Here is the notation. Okay, so sigma and suffix we need to write P. Okay, so P is predicate. Okay, so P, it stands for predicate, and sigma, it is the Greek letter. Okay, and P is predicate that represents the condition, and within parenthesis it is the table name. Okay, so on what particular table you are doing this operation. So this is the notation, and how this is given, normally we will write it in a form of a query. Okay, so let us consider, for example, R is a table. Okay, so and this table you are doing some select operation. So what is the operation we are going to do is like we want to display all the rows where the value of the column A matches with the value of the column B. And okay, so what is the meaning of this operator? Okay, so this is a and operator. Okay, so one more condition, what is given, the value of D should be greater than 5. Okay, so both the condition that has to be satisfied. Okay, so first it will check for what are all the rows which is having the value of A is equal to B. Okay, so what is A? A is one column and B is another column. Okay, so it will observe each and every row and it will compare which are all the rows which is having the value of A is equal to B. So here, this is one row where the value of A is equal to B, and this is another row where the value of A is equal to B, and this is the third row. Okay, so out of 4 rows, so when this condition is processed, it is able to select these 3 rows. Okay, and one more condition, and the value of D should be greater than 5. Okay, so the value of D should be greater than 5. Okay, so in that case, and out of all these 3, and it will also check, okay, which row is having the value of D which is greater than 5. Okay, so here we see that the value of D is greater than 5, but this row we see that the value of D is not greater than 5. So this, and out of these 3 rows, this row will be eliminated. Okay, but the last row we have the value of D which is greater than 5. So from the 4 rows, initially 3 was selected, and after 3, when the second condition was processed, and we are able to select only two rows from the all the collection of rows within the table. So this is about the select operation. And the next one, the same, how we will be writing it in a form of a query. Okay, so we all know that you have your employees table, and this is an example employees table. Here we have an employee ID, name, department, and salary. And there is a question like you want to retrieve the employees for working in the IT department and also with the salary which is greater than 65,000. Okay, so how will you write it in a form of a query? Maybe select asterisk from star from table name where department is equal to ID, okay, and salary greater than 65,000. Okay, this is how we will be writing it in form of an SQL statement. The same if you write it in the form of relational algebra. So sigma, okay, so sigma, and within bracket you have to give the condition. Okay, what is the first condition? The value of department. Okay, so department must be equal to IT. Okay, so and out of all the five, okay, so and we see that this first row is having the department is equal to IT, and third row is having the department is equal to IT. And one more condition. Okay, so these two row is selected, and the second condition is salary must be greater than 65,000. Okay, and out of these two rows, we are able to see that the third row is having the salary which is greater than 65,000. So only this row will be selected. Okay, so and this is how you have to give the you have to write the relational algebra. So sometimes they will give you the SQL query, they will ask you to write the relational algebra. Sometimes they will give you the relational algebra and then you will be asked to write the SQL query. The other way around, both the ways you should be able to write, okay, the answer for the question. The next operation is the project operation. Project operation is represented by the Greek symbol pi. Okay, so by default, when this project operation is performed, if there are any duplicate rows, and all the duplicate rows will be eliminated. Okay, so what are all the columns you want to select? Okay, so select project, it focuses on what are all the attributes you want to select it from the table, okay, which is represented by a Greek symbol pi. So by default, okay, so we see that whenever you want the duplicate values to be eliminated, we give the keyword called as distinct. Okay, so select distinct followed by the column name. Okay, that is what we have already seen in the class. So this is how we give the representation for the project operation. Okay, so project operation, say for example, our relation R is a table. Okay, relation, the other name is table. And we have the attributes A, B, and C. Okay, and out of all these attributes, and we are going to select only the subset of attributes that is A and C. So how this is represented? Pi of A comma C. What are all the columns you want to select? I want to select the column A comma C and from the relation R. So and initially we had we see that we had A, B, C column, and after selection and we are able to retrieve the column A and C, and after that and out of which, and only if there are any unique values, okay, and all the duplicate, and here we see that alpha 1 and alpha 1 it is repeated, so only the unique values are retrieved from the table. This is about the project operation, and this is how we write it in terms of the query and how we give the representation in relational algebra notation. So say for example, you have your student table and the question is you need to project only the student ID and name. So how we'll have to write it? Result is equal to and pi and followed by parenthesis. Okay, you have to open up a parenthesis and you have to mention what are all the columns you want to select, and then you have to mention from which table you are doing this operation. Okay, pi, and then followed by a parenthesis. Okay, what are all the column, and you have to close the parenthesis, and then which table it is functioning. And the next operation is third one. We are going to see about the union operation. So union is an operation that helps you to combine. Okay, so when you want to have combination of instances, when you want to retrieve the instances from more than one table, then we will be performing an union operation. Okay, so and this union operation is represented by the symbol, the set operator, that is u. Okay, so it is represented by the set operator. So by default, when you perform an union operation, this will help you to retrieve all the distinct rows from both the table. If there are any duplicate rows are there, the duplicate rows will not be shown. Okay, so only all the distinct rows of both the table. Okay, so only all the distinct rows of both the table will be displayed to the user. So, if you would like to perform an union operation, there are certain conditions that have to be satisfied. Okay, so whether it is union operation, or it is intersection operation, or it is a set difference operator, it has to meet up with certain condition. Okay, so what is the condition is like, the input table must have the same number of attributes. So both the table should have the same number of attributes. And say for example, if table 1 is having 3 attributes, table 2 also must have 3 attributes. This is the first condition. And second condition is, the data types of the attributes of both the relation should match. Okay, so out of the 3 columns, 2 you have given it as a character data type, 1 as a date data type. The same way, the other table, 2 should be of a character data type and 1 should be of a date data type. So this is the condition that we need to keep in mind. And what is the general syntax for the representation of union operation in a relational algebra is, the first table name R union S. Okay, so an R and S are the input relation upon which you are able to do some computation. Okay, so the resultant table will be one single relation which comprises of instances of both the table. Okay, the result will be a one single, a new relation which will include the instances of both the table. This is the representation, general syntax for the representation of union operation. So for example, you have two relations R and S. R is having the instances alpha 1, alpha 2 and beta 1, and S is having the instances alpha 2 and beta 3. So union operation will combine the instances from both the table. Okay, we will have alpha 1 and then alpha 2, it's there in both the table. So it will not be repeated. Okay, it will retrieve only the unique instances of both the table. And the next instance will be beta 1 and the last one will be the beta 3. Okay, so that will be the result. Okay, and after performing a union operation between these two relations. So for example, we have two table, student A table and we have student B table. So when you would like to perform the union operation, as I've already told that the number of attributes of both the table, the data types of the column, everything should match. So the representation is, result is equal to the first table name union the second table name. Okay, so it is the first table name union second table name. So when you perform an union operation, it will combine the instances of both the table. Okay, so 101 John 20 mathematics, 102 Jane, 22 physics.
Ma'am,
Then, yes, so you need any clarifications? Somebody call me. Okay, so the next is like, and after performing the union operation, we are able to get the instances all four in the resultant table. And set difference, it is a relational algebra operation that will include the rows which are present in the first table but not the second. Okay, so we have first table 1 which has some collection of instances, and table 2 which has some collection of instances. Both the table will have some instances in common. Okay, all the common instances will be eliminated. Okay, so the set operator will include the result only in the first table, okay, but not in second. If there is anything which is there in common between the two table, such instances will be eliminated. Okay, and set difference operator is represented by a minus symbol. Okay, this is represented by a minus symbol. And in order to perform the set difference also, the following two conditions must be met. That is, the number of attributes of both the relation should match, and the data type of the corresponding attributes also must be compatible. Okay, and this is the representation. The general syntax of the set difference operation is R minus S, where R is the first relation, S is the second relation, and the result will be produced in a new table which includes the rows that are present in the first but not the second. Okay, so say for example, we have two table R and S. So when you perform a minus operation and we see that alpha 1, this will include the results of the first table, the tuples that are present in the first table but not the second. It will include the tuples which are there in the first but not the second. Okay, and you see that alpha 2 is the tuple which is there in the second table. So such row alone will be deleted. Okay, and the remaining rows will be printed in the resultant table. The remaining rows will be printed in the resultant table. So we have two table, okay, and here we have the student with the register number and 101 and 102 and 103 is there, okay. And as per the set difference operator, this will include the rows of the first table but not the second. Okay, in that case, 102 is the row which is there in the second table as well. Okay, so this will include the tuples of only the first table. So 101 and 103 will be there in the resultant table. And a Cartesian product. Okay, so the next operation is Cartesian product, and this can also be called as cross product. Okay, and this is a mathematical, the relational algebra representation. It is given as a multiplication operator, and this operation will combine each row from the first relation with every row of the another relation. Okay, each row from the first table is combined with every row of the other relation. Is say for example, R is a relation and we have the tuples alpha 1 and beta 2, and S is another relation with four tuples. Okay, so and then cross product, what it will do, it will take the first row and it will multiply it with all the tuples of the second row, and then it will take the next row and then it will multiply it with all the rows of the second table. So if the first table it comprises of 5 instances, and if the second table if it comprises of 6 instances, and the resultant table will have 5 into 6, which is 30 instances will be there in the resultant table. So, how the operation takes place, alpha 1 will be taken and it will be multiplied with alpha, the first row, alpha 10a. And then alpha 1 will be taken and multiplied with beta 10a. And alpha 1 beta 20b, alpha 1 gamma 10b. So similarly, the process will be done for the second tuple of the first state. Okay, so beta 2 is taken and which is multiplied with alpha 10a, okay, and beta 10a, beta 20b, gamma 10b. And this is an example. We have the student table and the course table. And the representation when you want the Cartesian product to be performed. So we need to give the representation as result is equal to students multiplication courses. Okay, and each row is taken and it is multiplied with the other row. Hence, we have two rows in the first table and three rows in the second table. Okay, and we are able to see that we are able to get a multiplication of the tuples of both the table. And the next one is the rename operation. Okay, so rename is an operation that helps you to change the attribute name within a table and without altering the data itself. Okay, so you need not bring in any changes to the data values that is stored, but rather you can bring in change to the attribute name where you can assign new names and the generic syntax to perform the rename operation in the relational algebra is row and within parenthesis what is the new attribute name and then slash what is the old attribute name. Okay, so and row it represents, this is the symbol for the rename operation, and the new attribute name it represents. Okay, so new attribute name, it represents row, it is the rename operation. And new attribute name, it is the new name that you are giving or you are going to assign it to the attribute. And original attribute name, it is the existing name of the attribute. And R is the relation. Okay, and R is the relation. This is the generic syntax. And say for example there is an employees table and there is a column name called as full name. Okay, you want to rename this column, you want to change this column name to the employee name. Okay, and also you want to change the column name department to dept to department. Okay, so and how will you give this condition? Result is equal to row of what is the first you have to give what is the new column name. Okay, so new column name is employee name and right slash what is the old name. Okay, old attribute name is full name, comma you have the department, okay, which is the new column name, comma old column name which is dept. And also you, and after that, after giving all the old name and the new name, you have to close the parenthesis and you have to mention on what particular attribute on what particular table you are performing this operation. Okay, so and the next is an example, and you can all take down this example as an assignment and make a note of this question. We'll be discussing the answer for this question. Okay, you can take if you want to take a photo. The question is you have to give the relational algebra notation for the given question. Okay, so we have seen in today's topic the basic relational algebra notation, and we have seen about the select operation, and we have seen about the project operation and union, set difference, Cartesian product, and rename. Okay, so these are all the operation we have seen in today's class, okay, in the relational algebra notation. So I want everyone, you can please take a photo even. This is the table, okay, this is the schema, and loan is the table name. These are all the attributes. Depositor is the table name. These are all the attributes. Borrower is the table name. These are all the attributes. And these three are the question. Okay, we have to find all the loans over $1,200, and you need to find the loan number for each and every loan of an amount which is greater than $1,200. Find the names of the customer who are either borrower or depositor, or either borrower or depositor. So hope you have taken down the question, a screenshot or a photo in your mobile. I'm going to stop sharing my screen. So hope you have taken down the question right, okay, which is very important with regard to your first internal assessment. Did you all make a note of the question? Did you understand how do we give the representation of relational algebra? Can I get some responses? Lennon, Lennon, what happened? Lennon alone give some response. Okay, I have to show the question once. That's what I asked you all. Okay, so I'll show the question once. Yeah. I'll show the question once. Any other concerns you have? Should I need to show the table also? I'll show the table. Hope you have made a note of the question. Before the question, you have this schema, three tables. Can I stop sharing my screen? Is that okay? This is the schema. Okay, so Lennon, hope you have taken down, and every other student also have taken down. You have to give the relational algebra notation for the given question. Okay, so right now you can answer attendance. Jeshwin, you have to unmute and respond. Jeshwin,
Ma'am.
okay, I don't want any chat responses. You have to unmute and respond.
Yes, ma'am.
Okay. Miraj,
Present, ma'am.
Darshini, Darshini absent. Jivas,
Ma'am, unmute me.
Jivas,
Present, ma'am.
Nitin,
Present, ma'am.
Ashwin, Ashwin absent. Ashanger,
Present, ma'am. Ma'am,
Ashanger already absent only. Ashanger, are you there on the call?
ma'am, Ashwin present, ma'am.
Okay, Ashwin, you can leave. Okay, I'm moved to the next student. What about Ashanger? Are you there on the call? Okay, Ashanger has already decided he'll be marked absent. Ashanger, you are not there? Okay, no response. Aishwarya,
No, ma'am, I am there, ma'am.
where? At your entertainment arena, va?
No, ma'am, I'm there, ma'am. In the beginning itself, I'm there.
Then why when I'm calling your name, you're not able to respond?
And my
Huh?
headphone problem, ma'am.
Even now, I called you repeatedly.
Yeah, ma'am. My head.
Let us have a discussion later. Aishwarya, are you there on the call? Absent. Okay, you have to unmute and respond, students. If there is no response, I may understand that you're not there, okay, in the meet. Hannah,
Present, ma'am.
Steny,
Present, ma'am.
Nirikshana,
Present, ma'am.
Neetambika,
Present, ma'am.
Ramsita,
Present, ma'am.
Bhuvanesh,
Present, ma'am.
Nitish,
Present, ma'am.
Befina, absent, Ankit absent, Saroj,
Present, ma'am. Present, ma'am.
Atish, why two present? I just called Ankit recently. Why two guys are responding? Saroj,
Present, ma'am.
what about Ankit?
I'm present, ma'am.
Atish, Zero, Maria,
Present, ma'am.
Suryanarayanan,
Present, ma'am.
Darshini,
Yes, ma'am.
I'm zero present.
Alan,
Present, ma'am.
Ashwin,
Present, ma'am.
Rajavel,
Present, ma'am.
Sheetal,
Yes, ma'am.
Yashwant,
Yes, ma'am.
Lennon,
Present, ma'am.
Shania,
Yes, ma'am.
Irban,
Yes, ma'am.
Priya,
Present, ma'am.
Surya Bharani,
Present, ma'am.
Abhijit,
Present, ma'am.
Revant,
Present, ma'am.
Bhargav,
Present, ma'am.
Joel,
Present, ma'am.
Nitish,
Present, ma'am.
Santosh,
Present, ma'am.
Elgin,
Present, ma'am.
Vishwanatha Pandian,
Present, ma'am.
Daksha,
Yes, ma'am.
Pooja,
Yes, ma'am.
Agnal,
Yes, ma'am.
Vasantam,
Present, ma'am. Present, ma'am.
Monica,
Present, ma'am.
Yash,
Present, ma'am.
Subaranjana,
Present, ma'am.
Harini,
Present, ma'am.
Merrick, Merrick, 7140, Merrick is there. Merrick is there on the call or not? Merrick absent. Pranav,
Yes, ma'am.
Harshan,
Yes, ma'am.
Abhinav, absent. Sujit,
Ma'am, present, ma'am.
Sujit,
Present, ma'am.
Shalina.
Yes, ma'am.
Okay, so I'll read out the absentees for today's class.
Ma'am,
Number
messenger present, ma'am.
number 5048, 5107, 7018, 7027,
I have
7146,
7027 present.
7146. Why you didn't respond at that time when I called you? Hmm?
Ma'am, I respond. Ma'am.
Okay, there are 4 absentees in today's class. Complete this assignment and come when you come for the next class. We may all leave the class right now. Thank you all.